Hello, my name's Chris Kurzik, and I'm the Principal Engineer at Athabasca Engineering Solutions, AES for short. And what does AES do? Well, first of all, we provide third-party value evaluations. We provide training and certification. We provide equipment re-rating.
So we're going to look at today the jurisdictions. We broke that out from part one, so we could talk about a bit about the Canadian jurisdictions in particular. We'll start off with CSA, the Canadian Standards Association. That's the governing body for the pressure vessel equipment in Canada. We have in particular, we're going to look at the Alberta requirements in this video. They're outside of Quebec, they're the largest jurisdiction and they have the most documented requirements. And so that'll be the focus. We'll look at this Safety Codes Act, CSA. Then we're going to look at um, the PESR, which is the pressure regulation. And then we'll look at the exact series of AB series requirements. Just to be thoroughly clear, there's a hierarchy with jurisdictions in Canada. So CSA, of course, we said before, was the national requirements, but you have to be aware that there are also local jurisdictions. Every province in Canada has a jurisdiction pretty much, and they have their own specific requirements. In the case of fitness for service, their requirements can vary quite a bit from province to province. Um, the requirements for BC, Alberta, and Saskatchewan are very similar. Manitoba is quite different. Ontario is sort of standalone because they have sort of they're heavily influenced by the nuclear industry, so they have a different approach. Quebec operates under its own has its own requirements, and the Maritimes. I'm unfortunately I haven't worked in that part of Canada, so I'm not certain about that, but I'm sure they have their own set of requirements, probably more specific to naval requirements. So when we start with jurisdictions, we need to start from the top, which is the National Standard of Canada, CSA, and let's see what they have to say with regards to fitness for service and their jurisdictional requirements. I reference in this presentation CSA B51, the 2024 edition. Let's take a look at 7.6 Integrity Management Systems, IMS. Owners are responsible for ensuring the safety of their pressure equipment throughout its life cycle. Integrity management programs are one tool that the owners may use to document their program for addressing the required inspection, examination, testing, and servicing to the end of life determination for any kind of boiler, pressure vessel, or pressure piping they operate. So notice here that they don't talk about uh, like non-pressure equipment like tanks. There's if you we're going to look next at Annex Q for guidelines for the development of the pressure equipment integrity management program. So Annex Q is entitled the guidelines for the development of the operation of a pressure equipment integrity management program, an IMP. So they don't provide any specifics. This is basically for information. So when we dig through this, we find that the first relevant section is Q42, Integrity Management Program Planning. And all it says is that the owner or user shall establish documented plans and schedules for inspection, condition monitoring, and other activities related to the IMP. It also goes on to say in 7.2, performance monitoring and measurement, the owner/user shall establish and maintain documented procedures for periodic monitoring and measure of performance to an integrity management program. Performance measures shall include, for example, conformance to the established requirements and acceptance criteria, and that could be the for example, that could be the wall thickness of a pressure component. And B, the effectiveness of achieving the objectives and the targets. So that could be, looking at the rates of degradation of the equipment. So you can see CSA doesn't really offer a lot of very specifics. They just to sort of establish some guidelines on how to develop a program. And as we'll see in future slides or presentations, that this is why there's so much variation from jurisdiction to jurisdiction within Canada. So in summary, CSA B51 requires an integrity management program. Okay, they need it to do this kind of assessments and evaluation. They also go on to say the fitness for service standard is not specifically mentioned, only the repair specifications, API PCC2, which is the repair of pressure equipment and piping, and it also references NB23, which is the National Board of Inspection Code. Now, when you read these, fitness for service drops out of that anyways, but they keep it pretty simple and they give the jurisdictions a lot of latitude. Now let's take a look at the Alberta jurisdiction. It's called ABSA, which is the Alberta Safety Authority. And basically they have a few sections here. The first one's called the Safety Codes Act, and it's called SCA. In particular, in at this time in 2025, beginning, they have a document called RSA 2000, and they refer to Chapter S1. They also have another document that's called a PESR, and it's the Alberta Regulation 56 2000. And then they go on and they have some other documents called AB series, AB 535, AB 512, AB 513, and AB 520. And they go on to look at the requirements for the alteration, design, registration based upon a fitness for service assessment. That's what AB 535 is about. Secondly, we have the owner user pressure equipment integrity management requirements called AB 512. And it's also called a PEIMS. It's referred to by that jurisdiction. The little bit more about AB 513, which you talked about, is the pressure equipment repair and alteration requirements. And finally, they have a lot to say about finite element analysis FEA guidelines regarding the use of FEA to support the pressure equipment design submission. And out of all the jurisdictions in Canada, I can't speak for Quebec, but Alberta has the most extensive guidelines out of any of the jurisdictions that I've worked with in Canada by far. So if you're working in, say, Manitoba, you may want to consider looking at how they do it, because there's a lot of good advice there. It doesn't necessarily say that Manitoba will accept that. the jurisdiction, but it has some really good approaches and that are effective. Document AB 535 has some very specific conditions for use, and we're going to go through those. First of all, the Alberta ABSA jurisdiction, they need to have a valid reason for not performing the repair. So they don't just grant it. You have to demonstrate why you're not bothering to do the repair. Sometimes there's issues like time constraints during the turnaround, or the repair could further damage the equipment. It could risk further safety issues. Are sort of examples. Um, Acceptable continuous service interval has to be um, established. The risk for operation without repair, it has to be very clear that the owner has accepted that responsibility. It's not on ABSA, and it's purely an owner responsibility. Procedures for the risk assessment and safety operation of the equipment. So there has to be, like an established a change process that gets reviewed, and risk assessment, hazard assessments, and those types of issues, so that the teams thoroughly understand the risks. The operation of equipment must be managed by an engineering and administrative controls, and the CSA has sort of outlined those requirements of having an integrity program. The record keeping and maintenance and monitoring programs must be is required, and in this case, so there must be inspection records maintenance, monitoring programs. So they may do some online thickness measurement, routine, thickness checks, or for looking for monitoring crack growth, and that kind of thing. And there can't be any changes in service. Say, for example, you want to, increase the pressure on that system, and this code is a post-construction code. So you'd have to go back to the basics to do any changes in service from that point of view. So you can't use fitness for service for that application. So what are the limitations to FSS? Well, let's look at that. The first thing is pressure equipment, public occupancy. That means like, for example, hot water heaters and or HVAC related items in buildings. That this program does not apply to that. You fix it or replace it, like kind of thing. PR devices and their flanged connections, something that it doesn't apply. New construction, because fitness for service is considered post-construction. It's a post-construction spec, and the rules are different. In upgrading of in-service pressure equipment, trying to re-rate equipment based upon fitness for service is not permitted. I mean, you still have to do, if you want to do re-rating equipment, which I do quite a bit of, you still do inspections, but you do the calculations based upon the the code, right, for the uprating, the new code, but you don't go ahead and use fitness for service to do upgrades. Alteration limitations. The document says that when the acceptance is for a limited period of time, a condition, it can expire if the interval has expired. Say, for example, you have an interval of 2 years. It can be acceptable before you have to do a reevaluation. Then, and you extend that, then the acceptance has expired. The monitoring system is outside the acceptance criteria. So if the cracks have grown beyond that with monitoring and crack depth, for example, then it's expired. So, and also when his service conditions have changed. One more thought. When equipment is sold, relocated, or re-rated, then basically the acceptance has expired. Okay, let's look at the diagram. So this is the flow chart found in AB 535, pressure equipment integrity assessment per owner using the PEIMS criterion. Now, the first question is, was the damage detected? If there is no damage, then you would continue the periodic integrity assessments as per the owner, the PEIMS. If it's yes, does the equipment meet the registered design? And if it's yes, then we would continue to do periodic assessments per the owner, PEMIS. Now, if it's no, will the equipment be repaired? Is the second question. Then you would complete the repair as per owner user, the manual and the cap, or following the ABSA AB 513 criteria. Will the equipment be derated? Because you can fix it, you can derate it. If it's yes, then you need to complete an alteration form, that AB 513. Next question, will the fitness for service assessment be performed? If it's yes, then we'll go to the next page. We'll talk more about that. If not, shut down and decommission equipment per the owner and program. So the next thing is we look at the part 2 of the National Board of Inspection, and we look at that criterion. So for example, if we do the assessment and it's yes, then we move on to the next. It says, does the equipment meet the registered design? And then there's the flow chart will say continue periodic integrity assessments as per the owner's program. And it references AB 512, which is one of the key documents we mentioned earlier. And if it's no, then we basically say we have to document the assessment as per the owner, user owner program. Now, if we have a fail when we do the National Board Part 2 inspection, then we have some more decisions to make, and we would follow API 510 pressure vessel inspection, and we would do the analysis of the corroded regions. And this is where we do a fitness for service assessment per section 7.4, which was valid at the time of this recording. And now if we say, yeah, we're okay, we pass, then we head down the path where we were before. If it's no, then we would go and do a full fitness for service test. And recall that the first step is to have a proper inspection report done prior to actually doing the assessment. And the next thing is we would decide whether we're doing a level 1 or 2 assessment. And level 1, as we recall, is a very basic calculation intended to be for the inspector level assessment, and it's the most conservative. So if that passes or fails, then we can go to a level 2, which is a far more detailed, and usually a fitness for service qualified engineer would do that one. And so and that's how we sort of drill through this. So then we go to the next one. We say, yeah, we passed that assessment. Now, does the owner have a fitness for service quality plan? And if it's yes, then we continue on to, is the FFS assessment within the scope of this quality plan? And if it's yes, then we can continue to complete the fitness for service alteration as per the owner user, the program. Now, if we go back to the left side here. So if we say we didn't pass that fitness for service assessment, then we'd have to look at alteration methods, right? So then we would go, okay, so if we go through the alteration methods and we do that, then basically we would follow the procedures as per the alteration procedures found in AB 513. Now, if we continue the other way, no fail, then we need to shut down the equipment and address the incident as per the manual. And now we go back to fitness for service. You have the option of going to do a level 3 assessment, and a level 3 assessment is usually involving FEA and a subject matter expert who can do that assessment. It's much more involved and it can take quite a bit of time, usually a few weeks if those people are available. And then we move on across the board here. So everything sort of dumps out into complete the fitness for service alteration as per 535 and 513. And that's the criterion or the flow chart for AB 535, the procedures that you would follow. So the pressure vessel news has some thoughts about fitness for service, in particular cracks. There's a lot to say, actually. There's an issue with the environmental considerations with, actually understanding the fracture toughness, which is KIC. I'll elaborate a little bit more. So they say the use of a plane strain critical stress intensity or fracture toughness KIC, whose value has not been reconciled with the environment under consideration, excuse me. And so basically what they're saying is the date when you're trying to find this toughness date measurement, you have to make sure that you understand the environment it's under, and if you don't, then the calculation may not be correct. There's also problems with these kind of values for use in, for evaluating cracks in welded joints. And that's because, there's a stress intensification factor, there's metallurgical thing, there's a heat affected zone, and all these things can, make and there's also the amount of strain in the welded joint, and all these things can change that criteria. The pressure vessel news. We're going to talk about crack growth rates because they have some other thoughts there about the growth rates. So they say crack growth analysis in the stress corrosion cracking HAC, and the fatigue regimes require incremental crack growth for a given cycle and for a period of time. And unless the authoritative data is available to be arrived at from tests done under the environmental conditions that are there, then it's quite difficult to do. So a lot of data for crack growth rates is based upon test data in the lab, and it doesn't rarely reflects reality, and so predicting crack growth rates is quite difficult. Crack cracked vessel in a stress corrosion cracking environment that has been subject to cyclic loading can really complicate things as well. The pressure vessel news has some thoughts also on inspection and data gathering, and for me, it's always been a lot of grief, especially in the early years when we did assessments and the inspectors didn't always understand the kind of information they had. But thanks to more training, the inspection data gathering has gotten considerably better. So this is our thoughts. So for cracks, methods used for determining the state of stress in a component should include capabilities to compute the stress distribution on the loading conditions and the structural configuration. Okay, so really understanding and being able to model the whole configuration. Basically, the other thing is defects must be accurately located and sized, and this requires the use of appropriate NDE methods, techniques by competent examiners in order to make sure that all the data is there and correct. And the capabilities of the equipment suitable for NDE techniques must have confirmation of competency of the technicians using them, and there should be things like calibration and all those other criteria that have to be followed.
I hope that you found this presentation useful and valuable to you. This was provided by Athabasca Engineering Solutions. We'd love to hear your feedback and your thoughts on further videos. And we'd love to hear from you. Maybe we can do some business. Please subscribe to our channel so you don't miss a thing. Take care for now.